Okay, today we're going to be talking about gases and how they behave. And one common gas law that we have to keep in mind is the ideal gas law. And I'm going to just write that on the board so you can see what it looks like. Okay, and what the ideal gas law is pressure times volume of that gas equals N. Now, if you haven't encountered N yet, N is the number of moles of that gas, times R, which we're going to solve for today. R is called the ideal gas constant, times temperature. Okay. Now, some students get confused about how we calculate R, and I'm going to demonstrate how we calculate R. The first thing you have to keep in mind is, what is STP of a gas? Okay. And what STP is, it stands for standard temperature and pressure under ideal conditions. So we use the Kelvin scale because there's no negatives. So with the temperature scale here, ideally that's going to be 273 Kelvin. Okay, that's also equal to 0 degrees Celsius. So we don't have a lot of movement with particles at that temperature. That's why we use it. Okay, and our standard, pressure is 1 atm. We make the numbers really easy here for moles. We use 1 mole of any gas. And finally, for volume, using Avogadro's law, 1 mole of any ideal gas occupies, it's a funny number, 22.4 liters. Okay? So we have our pressure, 1 atm. We have our volume, 22.4 liters, N, 1 mole of a gas. R is what we're going to solve for, and T is going to be our 273 Kelvin. So if we transpose this equation to solve for R, what we end up getting here is R equals pressure times volume divided by moles times temperature. Now if you notice here, nothing's going to cancel. We're going to have 4 units on this. It's sort of strange. So the ideal constant equals pressure, which is 1 atm, times our volume, once again, is 22.4 liters, divided by N, I'm just plugging in here our number of moles, in this case 1 mole of a gas, and finally times T, which is 273 Kelvin. Okay. Notice our units here. Before I calculate, nothing cancels. So this R value is actually going to have 4 units. It's going to have atm, liter, per every mole, Kelvin. And if we punch these numbers in, we get a value of 0.08206. And the nice thing about this is that it's a constant, and we can always substitute this value in for R when we're trying to solve for any of the other unknown variables.